As you get closer to getting to a point where it's no longer a toy or a thing that you're experimenting with, you need to put it into a real process. That's where the rigor and that kind of front end assessment with let's tackle the technical risks early approach really can make a big difference. Actually, the biggest challenge we see for our clients is how do we take that leap from a lab-based example right through to a scaled-up solution that can be deployed across multiple plants of the plant, multiple plants around the world.
ST Microelectronics has been driving edge AI innovation for over 10 years with intelligent microcontrollers, smart sensors, and advanced tools. Combined with a rich software ecosystem and a growing partner network, the company delivers energy-efficient, high-performance, and privacy-focused solutions for industrial, automotive, and consumer applications. My name is Junko Yoshida, host of Junko's Talk to Us. With me, I have Ron Wilson, technology editor and longtime colleague of mine, who will help me drill down deeper on the technology side of this discussion. Hi, Ron.
Hello.
All right. So today's episode is about domain-specific AI, focused on industrial applications. Actually, we found a perfect guest, Jamie Jeffs, Director of Industrial Instrumentation at 42 Technology, a UK-based product design and technology innovation consultancy. Hi, Jamie.
Hi, Junko. Hi, Ron. Great to be here.
So Jamie and I met in Nuremberg, Germany, at the Embedded World this year, where he was showing at the Synaptics booth a real-time inspection demonstrator for pharmaceutical manufacturing. So before getting to the details of this, first, Jamie, tell us briefly about your company, 42 Technology, and what your role is at the company.
Sure, thanks, Junko. It's a pleasure to be with you guys today. So 42 Technology, we're a technology and innovation consultancy, as you mentioned. We've been operating for about 25 years. We work across a broad spectrum of sectors in lots of different ways, supporting clients. Really, anybody that has a science or engineering challenge that needs our kind of support. Now, we work across consumer, medtech, life science, and my area of expertise, which is the industrial sector. Working primarily with three kind of core areas that we provide services, both in sort of strategy and insight, development and support for clients, product development, as well as what we call manufacturing innovation. And it's really that combination of our ability to help people in manufacturing and in industrial applications, as well as helping develop the sort of sensors and instrumentation that support the work they're doing. And that's my, as I say, area of expertise. That's my background. I've worked around 20 years in industrial instrumentation and sensing, working with a number of different companies, both in terms of development, but also in terms of the sort of commercial side, really working across lots of different industries, helping them solve problems, finding the right equipment to measure their process, understand what's happening, and really find what we call kind of actionable insights from that data. So no, it's really chuffed to meet you at Embedded World, talk about the line clearance application we were promoting with Synaptics, and great to be here today. So thanks for the invite.
You know, you just said line clearance applications. I covered computer vision long time ago. This was like 1990s. When I first heard about the computer vision, I thought, wow, this is going to change the world because those cameras can watch things carefully, what's got in, what's not got in. But then here in Nuremberg, you were showcasing the pharmaceutical production process, you know, and I realized that this is awesome, but I didn't really understand or appreciate that what it took to transition for company to doing the traditional conventional machine vision to AI-driven production line solutions. So, you know, Ron and I have been wondering if you could help us understand the steps people or companies must take, if possible, in a chronological order, if their goal is indeed to deploy AI in the industrial context, such as high volume production process. So walk us through, Jamie.
You've really touched on the main point there, which is a huge amount of industrial processes are now looking to see if they can leverage AI. And there's been a lot of development, and you mentioned machine vision. That's been around for a very long time. And there's a lot of companies out there providing some amazing tools that are allowing companies to start leveraging that. One of the challenges when you talk about domain-specific applications, like a high-volume production process, pharmaceutical, food and beverage, trying to find something that can be very specific to their application, trying to be able to do that in a way that can be verified, validated. It's really challenging. So companies are really keen to leverage the capabilities of AI and machine learning at the edge, which is a big part of what we were demonstrating at Embedded World. But you're right, there is a process that we're very familiar with being able to walk through with our clients to make sure that not only do they get the right solution at the end, but they've really understood their process and getting the most out of the tools that they're trying to deploy. So you mentioned about sort of chronological order. I think I mentioned it there. The first thing is, do you really understand your process? You know, it sounds silly, but actually, you know, there are a lot of companies who have established themselves over decades, maybe 100 years or so, and there'll be people in that organization that understand it inside out. But if you're trying to take that and put that into an automated system, for example, really you have to understand every step in that process to be able to deploy these tools reliably. So that's the first step. And we work with a lot of clients in actually, you know, working with their existing teams, looking at the institutional knowledge that's within that business to be able to understand that process. But the obvious next step then is to then capture the data and understand, does their understanding of their process reflect the data that they have within it? So you talked about line clearance. That's a very specific process of checking for any objects that might be present between batches. That's a very manual process traditionally. We were demonstrating an example of where it can be done in a fully automated way. But there are a number of things those people in that process will do to manually check areas. And if you don't fully understand that, then you won't deliver the right solution. So first understand that process, but then how are you going to capture the data that you can then use to analyze and validate against that process? So we work with clients a lot in those early stages, defining not just what their process is, but what are they trying to achieve? What is it that they want to be able to deliver? And beyond that, then how do they see AI and other tools helping them deploy that?
It sounds like he's saying that it's as important to talk to the line operators as it is to talk to the system engineers, because the operators may know things that the engineers didn't intend.
I think that's absolutely true, Ron, and we see that whether you're looking to automate a process, whether you're looking to capture data in a machine or a piece of plant equipment that's doing a very specific task, even down to the settings that are used to get good optimal performance or throughput. Yeah, absolutely. Ask the people that are there day in, day out and understand the process.
I think there's one more step though. In the first place, how they capture the original data, right? But that's one. And number two, if you want to have the really accurate data, you need to have some sort of platform that you can use to make sure that you continue to gather accurate data. Tell me a little bit about this data collection side.
Absolutely. And I think a lot of companies start from a different position. Some have invested heavily in putting sensors and instruments in that are capable of capturing that data. Others may only have points at the beginning and at the end of the process. You know, a lot of the challenges are around quality assurance, making sure that what's going in at the front and coming out at the end is as you'd expect. So in those cases, it can be very, very specific to the specific plant you're working with. And in that case, we work with a lot of our clients on understanding what current data do you have, how reliable it is, and if you haven't got that data, how do we help you get that data so that you can actually start building this picture of your process in a data model that then is going to be needed if you want to be able to deploy a lot of the sort of machine learning or deep learning tools that we're now talking to clients about.
It sounds to me like you're describing the classical process we were taught of identifying state variables and estimating the observability and controllability of the system.
Yeah, it is, Ron. I 100% agree. But equally, it's understanding then once you've got that established data set, how do you then analyze that and validate that against what real looks like?
What really happens?
Yeah. Yeah, we're working with clients a lot in terms of doing that initial step. And it doesn't have to be, you know, particularly onerous. I mean, if you've already got existing sensor solutions that are giving you good outputs, a lot of these companies will have well-established automation systems that are capturing data. But it's almost, how do you understand that data in a way that it can be interpreted with what's actually happening in your process? And sometimes that's about combining data. That can be what we call sort of sensor fusion, where you're using multiple sources to give you a good sense of what's happening across an entire production process. And it's only really once you've got that understanding of the process, you've analyzed the data that you've got, you've established, you know, data points that perhaps you didn't have previously, that you can then really start to model that. And then what we would say, which is to measure and validate what you've found. Has it reflected the real world? And that then gives you a really strong platform to then start looking to deploy solutions that can be both available commercially today through a lot of companies that are sort of developing their own platforms for machine learning, deep learning, generative AI, and really then equally, if you need some bespoke solution, you've got an even better platform with the data you've captured, the way you've validated that, and the way that you've modeled and understood it within your process. So it's you know, it's not always the most exciting part for companies, but actually we advocate the need to do that. You know, certainly identify those big challenges you've got in your process in terms of how do we successfully deploy AI? Because ultimately, any tool that you use, especially in these processes which are so strictly governed by regulation and have, you know, big impacts if you get something wrong. If you're going to deploy a level of automation or deploy a level of artificial intelligence, the people that rely on that data need to trust that data, and trust is a big part of, you know, implementation.
Yeah. This sounds very different than the philosophy I hear from some of the more determined AI enthusiasts, that what you really want is end-to-end AI, and as long as you capture all the inputs, you don't really need to know anything about the system. It sounds like in your embedded world, that's not the right direction.
I think our experience tells us that, you know, we all understand the value of trying to get to something quickly. There's a huge drive to be able to have AI in the process, and we're absolutely behind that. I mean, it is absolutely a non-negotiable point now. You know, AI has so much potential to be able to support these industries. But we also know from experience that if you don't take these steps, and as I say, they don't have to be particularly onerous, but you need to at least assess that before you effectively start to really hand over you know, a lot of your core processes to things that hopefully will, as we know, learn and develop and create their own added value and those insights that everybody wants to benefit from. So no, I don't think it dismisses that desire, Ron. I think it's just an understanding that there are some core principles here that I think if you're looking to do something, you know, novel or innovative with AI, then you need to be able to have the confidence from an early stage. Once you have that confidence, it gives you a much greater chance of success as you start deploying these tools onto production processes.
But as we talk about the industrial domain, what really struck me is that this is not a greenfield AI deployment. We're talking about companies who already have the conventional production process, right? So you have to kind of retrofit wherever you can to put this AI thing in. So how do you do that? Where is the right place to insert yourself as an AI agent or whatever it is? I mean, how do you do that?
That's a really good question. And I think, you know, all the sort of surveys and stats and things indicate there's a huge desire from industry to start leveraging those tools. And I think you're right. Where do you start? It's a great question. We've worked with clients across a number of different industrial processes. Ultimately, it's about value. What value is this going to bring? What major operational impact or production efficiency does it provide? We talked about quality and safety earlier. You know, those things are critical. If it can add that kind of value where either you're producing better, higher quality products, more reliable, or a greater throughput of what you're producing, or equally, you're preventing an issue from occurring because you've got greater visibility of what's happening in your process, but also you've got better, deeper insights into what's happening, so you can really improve and or prevent things that shouldn't be occurring in your process. I mean, we've all heard the stories about, let's look at pharmaceutical lines, you know, the wrong types of pills being put out into the shops with the wrong label packaging. Those types of things have, you know, significant impacts, not just on the consumer, but obviously on the reputation of the companies, but also the costs of recalls. So yeah, from my perspective, you really want to start by looking at the things that are going to give you the greatest value. But equally, if you're starting from a low base, let's say you don't have the data that we talked about earlier, maybe an area where it can be, you know, isolated and you can be able to see that kind of return more quickly in a specific area of the process. I mean, we looked at line clearance in our recent project because it is almost like a standalone process within these facilities. They have to do it from a regulatory perspective,
Right.
but at the moment, the solutions, there are, you know, a number out there, have challenges around, you know, the types of imaging that's used, the breadth at which they can inspect the area, and there's still, you know, a huge amount of manual process required to do along with a lot of these checks. So yeah, understanding a specific area where AI is going to create value for you, but you can also validate and, you know, test that these things are going to give you the results that you need, and a platform that you can improve upon as well.
We, especially technology reporters, we tend to understand the process in a very, very simple terms. I'm talking about deploying AI in the industrial domain. First, let's pick a hardware, see what models are available, and find out what tools they have to help us implement AI. That is the understanding that how they can actually deploy AI. But as you already explained, it is not that simple, right?
I mean, I think in a research level, that's often a good place to start. And, you know, I think that's where a lot of companies and corporate organizations have started, is at the research level where you can, as you say, take that approach. But as you get closer and closer to, and we talked about this in Nuremberg, you're getting to a point where it's no longer a toy or a thing that you're experimenting with. You need to put it into a real process. That's where the rigor and that kind of front end assessment with the kind of let's tackle the technical risks early approach really can make a big difference. And yeah, so I think whilst it's absolutely, you know, a lot of people are exploring what they can do with IoT workloads of a lot of these different hardware options that are out there now. I think there's ultimately some huge value in when you start trying to put that into real processes, understand these challenges, understand, as you said earlier, Junko, where do you want to start? And then that value. What is it that the value is going to return from investing in this solution? Because it can be, you know, a very iterative process at times. I know, I think, like you say, everybody wants to just, right, we'll start experimenting and we'll start deploying and see where it goes. And if companies have got the capacity and the capital to be able to do that at large scale, that's great. But actually, the biggest challenge we see for our clients is how do we take that leap from sort of a lab-based example right through to a scaled-up solution that can be deployed across multiple plants of a plant, multiple plants around the world. This is what really I think industry is looking to be able to do, and I think, you know, we're getting closer to the point where that can be done, you know, in a lot more reliable ways, but you still want to go through that sort of rigor and that process to be able to make sure it's done in the right way.
Yeah.
Yeah, it seems to me that one of the steps in this process is still pretty much art and experience. And that is, you have a model of the system, you have collected data. How do you select an AI model?
Well, it's a really good point. And I think there's, a huge amount of solutions out there. I think what we've found in our experience is those that offer, so we talk about sort of the sort of open source models that are available to be able to experiment with. I think working with companies that know how to develop model training for solutions in the industry is very valuable. But also, I think there's an open source nature to the hardware that's being developed that's going to be really important there as well. Because I think one of the considerations, Ron, is that scale up capability. And if you're thinking a bit further ahead and trying to understand, well, we can get this to work on a small pilot line somewhere and it'll work really well, but that requires us to build a systems architecture around it that locks us into a particular type of approach or a particular type of connectivity, then that can be a real barrier to being able to scale these solutions in the way that we've talked about. So I think the more vendors can provide that sort of open source environment for people like ourselves, OEMs that are trying to embed these solutions into their equipment, integrators and others, the more that gives the domain specific applications the chance to be able to scale in the way that we spoke about. But the model selection, yeah, I think there's a huge amount of options out there. But again, it's about taking something from perhaps a lab or research level to something that can be deployed reliably and has all the sort of inbuilt security as well to those types of models and systems that are being deployed now.
I just kind of summarize what we have talked about as the key to the successful AI deployment in the industrial domains, right? And I want to go through step by step, as you previously laid out, Jamie, that I totally fully understand the importance of understanding specific industry applications.
Yeah.
And then you did briefly touch upon this need for the open development environments. Why is that important? Can you elaborate on that a little bit further? I think you mentioned the scalability could become the problem if once somebody already developed something in a closed development environment, it is hard to scale that to a large mass production lines. And that's the way I understood, but maybe you meant something different. Tell me more about why open environment is important.
No, I think absolutely it is about being able to scale, but I think it's also about being able to deploy different solutions in different ways. So I think whilst it's important that these tools are made available and they're very powerful. These things can enable you to really test and validate what you're doing and then start implementing and learning from it in the way we described earlier. But it also means that a lot of these industrial processes have many, many different points for measuring, for gathering data. If you have a restrictive environment for each different device, and if you think about the types of companies I work with in developing new products for these industries and these sectors, I think they've got a choice fundamentally. Either you continue to be the company that provides the hardware and the measurement expertise, or you try and provide that sort of full range of services, which ultimately means, what are they providing? They're providing data. And how do they do that? They provide that through, sophisticated, high precision instrumentation often. But if you then restrict the user to only being able to access that data through a certain model or a certain development tool, and don't make that open, both in terms of the way that the systems can be developed, but then also deployed, this is then restrictive, where you've got companies that are maybe having 100 different measurement points across a particular process. And in that case, you need that open environment, not just to scale, but also to be able to make the most of the data that you're gathering, and be able to, make the most of AI, quite frankly. And that's something that, OEMs, as I described them, people that are making the equipment that generates this data, that's a decision they need to make strategically. Do we want to be specialists in what we do in terms of measurement and performance, or do we want to offer that sort of full service? And if you do that, then needing to provide those open data connectivity tools is going to be quite an important point in that transition to that type of full service provider. So it's a really interesting point, Junko, in terms of strategically, how do these companies want to grow, but also how do they want to develop these tools that as I say, many of these new AI models are able to do.
That reminds me of, as a news reporter, I report a lot of companies in recent months and years that a lot of acquisitions going on. Chip companies acquiring tool companies that frankly I have never heard of before. And I'm thinking, why is that important, right? But then I realized that there's a whole supply chain of companies who offer platforms, companies offer tools, it's a web of supply chain that I wasn't even aware of. Walk me through. You just mentioned that there are two types of companies, but tell me a little bit more about that, because you're in the position as a consultant to pick and choose which supply chain guys that your clients may be the best fit. Can you give us some overview on supply chain?
Yeah, absolutely. And it's a really important point because obviously you may think of at one end, I guess, the chip vendors who are providing these, we're talking a lot about edge-based devices for AI compute now. And at the other end of the end user. But as you say, there's a huge number of important players in the middle, if you like, that are helping making those decisions about which chips and which solutions to deploy, as are the users. In terms of the ecosystem, if you like, for supplying these things. You can look at it as end users really are the ones that, let's say, a pharmaceutical company or a food and beverage industry. To get those solutions implemented, a lot of them have to rely on integrators. These are people who are agnostic to the systems or devices, but are able to bring those devices into their plant and integrate them into their solutions. You mentioned earlier the need to retrofit. A huge amount of the opportunity here is existing plant, historical sites. So you need that integration capability. Below that, then you've got the people that actually provide the equipment. You call it OEMs, and that may be the plant machinery itself, or it may be the sensors and instrumentation. And then behind that, then obviously you've got a huge supply chain of people that are developing measurement cells, AI edge devices, the IoT and comms connectivity solutions. So a huge range of companies in that mix. You mentioned M&A, and I think that's very important because I'm seeing a lot of the big players looking to leverage this are bringing those capabilities in-house through acquisition.
Right.
But actually what I'm seeing more and more now, as I'm sure you guys are the same, is this concept of partnerships and strategic partnerships to be able to deliver that range of services and that supply chain. I think increasingly end users are looking for the complete solution. So if you can't provide that through your core competency as a company, if you develop sensors or you're developing chips, then partnering with people that can support that, building that supply chain for the user, and then being able to leverage that relationship to put those kind of solutions into process. I'm seeing a huge amount of activity in that, and we're no different. We're partnering with a number of different companies to be able to broaden the offering we can offer our clients, and it just gives them the flexibility, the capability, but also that access to market that otherwise would be very challenging to enter.
Speaking of complete solutions, you mentioned a few moments ago one of my favorite words, security. Even if you're getting a complete solution from someone, does anybody really understand the attack surface that we're introducing by adding AI to an industrial system? And whose responsibility is it?
Two great questions. I think absolutely it's at the forefront of most companies' minds when they're thinking about deploying these solutions. Do they truly understand it? I think do any of us, unless we're cybersecurity experts, that the pace at which both the people trying to access and the people trying to protect from it. But in terms of the awareness of it as an issue, absolutely. I mean, in the industrial sector specifically, it's still a huge concern. And a lot of the sort of forefront solutions were relying on cloud solutions. They've tried to sort of access that industrial market and found there's still a huge reluctance to allow certainly any of their data to leave site, but also you need that assurance that any device you're putting into their process is not going to be a weak point in their process for people to access their network and cause sort of the kind of havoc we see in some of the news reports and some of the, certainly in the UK recently, we've had a number of our retailers having access issues, and therefore, I think one of our major retailers was basically not able to do any online transactions for several weeks because of a cybersecurity attack. So, Ron, I think it's absolutely at the forefront of most companies' minds. In terms of, the understanding, as I say, I think they do rely on people within that supply chain to give them the assurances that they need. But in some cases, they will just have a blanket ban on, let's say, cloud-based solutions because they do not want data leaving their site.
Security is one thing that Ron and I talked about. And the other thing is that verification and validation. In other words, that we spend a lot of money in AI, and it looks like it's working okay. But how do you verify that your investment in AI actually bores fruits?
It's a great question. And I think ultimately it's a massively important step because we talked about it earlier. Trust in these solutions is critical. I'll add to that as well that in many cases, if an industrial process operator is trying to install something new, they'll often start in one location. And it's the success or failure of that installation which then opens the door for people in that supply chain or those companies to roll them out. So if it isn't proven to work correctly or validated, as you say, it can be a big issue. It depends very much on the process, but I'll actually come back to the point we made earlier. If you've got good base understanding of what normal looks like, what is our process actually doing, and can you measurably see a change in or an improvement as a result of those tools that you're implementing? So again, it would be very difficult if you had no initial data on the performance of your process or unreliable data. It's the foundation we often talk about understanding process, to be able to then verify and validate. But of course, there are a number of different ways that you can do that depending on what the application is. But it's incredibly challenging. It's incredibly important. But it's also something that most companies looking to implement these solutions understand that there's an iterative process to deploying AI. And that often requires, improving, optimizing, validating what you're doing. So, yeah, no one single answer, I'm afraid, to that, Junko. But ultimately, it's all about the data, as I keep saying, from the start, and then how you implement it.
So we could be talking about really a conventional modification process of testing the new code in a digital twin, testing it on a pilot line, testing it in one production line, and then going public with it. And isn't that a multi-year process rather than a multi-month process?
It can be, but again, it depends on where you're starting. I think if you're trying to roll out AI across multiple locations on a particular plant and you've got 100 lines per plant and you're trying to roll that out, but actually I think a lot of companies, because you can build models and develop tools that are repeatable, where you've got control variables, you can then deploy with more confidence those solutions once you've been able to model and trial them. I think it's a really important point you make, Ron, because I think one of the benefits of AI, and not just deploying it, but using it in the way you develop, new approaches, and we're certainly using it within our business to help with our clients' work, is that it can also expedite some of these processes as well. So ironically, provided you've got verification, Junko, and validation of the tools you're using, you can also potentially use AI in ways to expedite some of the things that traditionally might have taken, as you say, many years of validation. So yeah, there's a huge desire to get things fast. I think there is the ability to do that in many ways, depending on the approach. But I also think there are tools out there that are helping companies to do that in a faster, more efficient way as well.
When you work with your clients, I think this is a hugely important process. And at some point, your clients who were seemingly eager to embrace AI and listening to you and looking at the process, things that they need to develop, things have to go through, they may say, Jamie, it's not just for me. What would be the deal breaker when you're trying to introduce the AI deployment in industrial context?
I think ultimately the deal breakers would be, I guess, security is one of them. If a solution is not shown to be secure, then that will ultimately lead to issues. But also if it's not implemented in the right way. And I think that's where we come back to, whilst it's attractive to rush to deploy these solutions quickly, actually having a strong foundation of, as you say, managing those risks up front, being able to understand what you're trying to achieve, having a clear specification. These are all very sort of common themes in product development and manufacturing innovation, but they can be applied to AI deployment in the same ways, and in many ways should be, to make sure that you can actually achieve what you're looking to achieve, and measure and validate that, and be able to prove that it's showing the kind of improvements that you'd expect. But yeah, deal breakers on security, certainly. This is why we're exploring a lot of edge-based solutions at the moment. it does allow industrial companies not to rely on cloud compute solutions to keep their data on site and to be able to really reduce, I guess, that level of risk that they see from perhaps having data leaving site.
Well, it seems to me that there needs to be a platform before you even start AI deployment project. There's a need for some kind of platform to make everybody involved in the project easily understand, facilitate their knowledge on what problems people are going to solve. I mean, if we have that platform right up front, maybe the rest of the process is a lot easier to manage.
Oh, 100%. And I think, that's something that, most companies recognize the value in, not just having the platform for the project itself, but the platform, from a systems perspective, looking at it as a whole system rather than just as a single area of deployment. So often it's, can be high level, and it can be, I'd say it doesn't have to be onerous. It doesn't need to be long-winded. You've got a lot of, experienced people in all across the supply chain we talked about that can help develop this understanding.
In order to close this session, I actually wanted to ask you wish list. You are the kind of enabler for all the AI deployment in the industrial setting. But from where you sit, what would you like the industry meaning chip vendors, tool vendors, AI model developers and so forth, what do you wish the industry to focus on, innovate further, so that your job of helping your clients get easier?
A great question, and I'd love to be able to have a lot of different things. But I think fundamentally, we talked about it earlier. I think the more open environments for development. I think obviously cost is a big driver, but actually cost is not necessarily just in the hardware. It's also in the time and effort required to develop these solutions. I mean, we've talked a lot about the rigor of process and the requirements to go through those steps. Actually having tools that allow you to then more rapidly then deploy those solutions in the environments we talked about makes a big difference. I think generally speaking, there are huge amounts of strides towards having industrial ready solutions for AI, but obviously a lot of the challenges we talk about aren't just about the performance of the silicon or the performance of the accelerators. It's also about the ability to deploy these in more harsh environments. So I think a lot of chip vendors are now looking at that and saying, if we want to be successful in industrial applications, we need to, either through partnership or through their own development, have solutions that can be more readily deployed in not so easy environments as perhaps the consumer world or consumer electronics or certainly in the sort of IT space. So yeah, open source development, having that ability to be able to deploy those solutions in more challenging environments. And also, I guess, just being able to, we talked about open connectivity as well, having that range of connectivity solutions so that once something can be deployed, it can be integrated more easily into those existing sites, existing plants. Because if you rely purely on only new build products, you won't see the sort of scale. Also, new build production sites, you won't see the scale or expansive deployment that we're helping our clients try and achieve. So yeah, those three core things really, I think, would be on my wish list.
All right. Well said. Thank you so much for coming to the show. This was a lot of fun. And actually, we should have part 2 sometime, Ron, don't you think?
Oh, absolutely.
All right. Thank you for coming to the show, and we'll talk soon.
Thanks, Junko. Thanks, Ron. Been a pleasure.
Bye. ST Microelectronics has been driving edge AI innovation for over 10 years with intelligent microcontrollers, smart sensors, and advanced tools. Combined with a rich software ecosystem and a growing partner network, the company delivers energy-efficient, high-performance, and privacy-focused solutions for industrial, automotive, and consumer applications.